Today we want to start looking at the second of the traditional two big questions of calculus, and that's calculating the area under a curve and above an interval. So we can draw a picture of it. A lot of times we just say area under a curve. So we have some function. I'm going to draw the same function that we all draw. And what we want to know is how much area is under the curve and above the x-axis between x equals a and x equals b, between two values of x. So that is the second of the two big questions of calculus. What is this area? And a lot of times we refer to this as the area under the curve, but we should include that this is the area under a curve and above the interval from a to b. So this is the part that I like to include. Area under the curve, y equals f of x, and above the interval so it's under the curve, y equals f of x. I forgot to write the name in. Yikes. It's the area under the curve, y equals f of x, and above the interval from a to b. So here's the interval from a to b. Down here. So it's whatever is sandwiched between the curve and the x-axis between the two values, a and b. The reason I phrase it this way is that when we start looking at multivariable functions, area under the curve has to get expanded, because instead of just having a one-dimensional curve in two-dimensional space, we could have a two-dimensional surface in three-dimensional space. And so we'll not talk about area under the curve, but say the volume below a surface, and not above the xy plane, because that would be the whole xy plane, but above some region in the xy plane. So we need to expand in multiple directions. So let's talk about how we're going to calculate the area. Oops. And we're going to summarize that with all we need to calculate area. Area is equal to length times width. Once we have calculus, once we start getting the ideas of calculus, all area is just rectangles. If we're calculating an area, length times width is all we need. All the area formulas that we have, we can get from length times width. The difference is going to be that instead of our length being a nice constant flat number, the length is going to be variable over the width. So what we're going to do is we're going to think of different shapes as being length times width, but the length is variable. So we're going to think of different shapes in terms of length times width, but where the length is a variable rather than a constant. We're going to classify different shapes. We're going to use length times width. Even for non-rectangles. Yikes. We're going to use length times width even with non-rectangles. We're going to consider all the shapes to be rectangles in which the length is variable. That makes them not rectangles anymore. But we're going to use length times width, and we're going to just say length is now a function, or length is now variable rather than being constant. So we're going to use length times width even with non-rectangles. We're just going to adapt what we know to make the length variable. We're just switching it up so that the length is now going to be variable rather than constant. Length will be variable. And that's what we want. We want to think of the length as being variable rather than constant. Once we can figure out how to multiply that variable length by the width, then we'll be able to calculate areas always using length times width. Any questions? That should raise lots of questions because you learned all these area formulas. And all those area formulas are things that we need to calculate all the time, like circles and triangles and rectangles and parallelograms and all those other shapes. And all the ones that you don't remember, like pentagrams, hexagons, and so on. So those are all niche cases that we derive based on length times width, or at least can be derived based on length times width. So the way we're viewing it is we're taking the base case we're going to put the interval down here. Down here, there's going to be some interval from A to B. The base case is where the length is constant. So I'm going to read this down here as the width. And then if we have some function that's constant, that's what makes a rectangle. So here we have a constant length. So the width goes from A to B, and here is our length. This constant length ends up being a rectangle. And the area is just the length times the width. What we're going to do now is we're going to make, instead of having a constant length, we're going to adjust this so that it's a variable length. So we're going to have the same kind of picture. We're still going to have this interval down here, x equals A to x equals B. That's still going to be our width. But then above that, we're going to put some function. And so at different points above the width, the length will be different. So here we have this small amount of length. And then we have a different amount of length here. And then here at B, we have a lot of length. The length is variable. Any questions? That's the first concept that we want to put in the bank when we start thinking about finding the area under a curve. We want to use area is equal to length times width, and our length is now going to be variable. We want to multiply. When the length is constant, we get to multiply. When the length is not constant, we have to do something else. So length is constant, we get to multiply. when the length is constant, to find the area, we get to multiply. If the length is variable, then we have to do integration. Then we have to do something else. If the length is variable, now we have to integrate. But this is what it's based on. This is where we start. Area is equal to length times width. The reason that I start with this is that this can be generalized to anything that we're multiplying. Distance, replace area, length, and width with distance is equal to rate times time. If we're traveling at a constant rate for a period of time, then all we have to do is multiply the constants to find the distance. But, so if the rate is constant, we get to multiply to find the distance. But if the rate is variable over the time, then we have to integrate. We have to upgrade our process to find the distance. Mass is equal to density multiplied by volume. If the density is constant throughout the volume, then we get to multiply the density and the volume to calculate the mass. But if the density is variable throughout the volume, then we'll have to integrate the density over the volume to find the mass. So what we're doing here is we are we're thinking of integration as multiplication in which one of the factors is variable. This is the thinking that we're trying to start with. This is not going to help us solve problems. This is going to help us understand integration. I just want to make that clear because you and I have different goals as to what we want to accomplish in the class. So the thinking is that integration is multiplication, but one of the factors is variable. Integration is multiplication, but one of the factors is variable. Anytime you can calculate something with multiplication, you can calculate it with integration. Area is equal to length times width. Distance is equal to rate times time. Mass is equal to density times volume, or area, or length. Work is equal to force times distance. That might be a new one for y'all. Any questions? Volume is the area of the cross-section. Multiplied by the length. Usually I say the height. Any questions? That's step one. We're going to start by looking at area under the curve. And we're going to justify always just using area is equal to length times width, because that's easily adaptable. The length can be a rate, the width can be time, and the product area will be distance. So that's why we start with just length times width. I need some multiplication that I can visualize. So we use length times width, and then we just need to learn to adapt. Anytime we've used multiplication to calculate in the past, we can use integration if one of those factors is variable. That's concept number one. Integration is multiplication, but one of the factors is variable. Let's pause the video here and then talk about next steps.